Okay, and then applied question with trigonometry. We've got a plane flying over a forest, and it says the altitude of the plane is 1,000 feet. That would be straight up from the ground. So I've got a right triangle. It's 30 degrees looking down at the forest fire, so looking up at the plane from the fire, which I wouldn't advise, would be 30 degrees. And in this question they want to know what's the distance from the UVA. The UVA is the drone that's flying in the sky. So how far is it from the aircraft to the fire? So I'm looking for that side there. I'm given the opposite side. I'm looking for the hypotenuse. So of my three trigonometric ratios, the very first one is the right choice. It's the only one that has the opposite and the hypotenuse in it. So S is for sine, and the opposite was 1,000. The hypotenuse is what I'm looking for. In this question, when you cross multiply, you do not get an answer right off the bat. This is a question where once you cross multiply, you're going to have to divide to finish. It takes 2 steps to get the answer. So dividing by the sine of 30 gives me 2,000 for the answer. Which looks right in the picture. Alright, but continuing on with the same kind of question. So that was the answer to question A, was 2,000. For question B, what's the distance from the fire to point D? Well, I'm using the same exact picture again. I have that this is 2,000. I have that this is 1,000. And I'm looking for how far it is from the flames to point D. Well, I could use the 30 degrees and use some trigonometry, or I could just use some Pythagorean theorem. I'm looking for one side when I have the other two sides. Just make sure that you put the hypotenuse as the largest side as C. So 2,000 squared minus 1,000 squared is 3 million. So x squared is 3 million. And square rooting that brings me to the length from the fire to point D, which would be about 1,732. Question C says that there's a camera that's on the drone, and this is showing off its range about how far it can actually take pictures. It says the field of view of the camera is 20 degrees. So that means that it's 20 degrees left and right combined. Looking at this picture, I can already kind of predict that I'm going to have to use that 20 degrees and separate it into 10 degrees and 10 degrees because of this angle bisector BD. The reason I know to do that is because I can't use trigonometry until I have a right triangle, and I can't use the 20 degrees because the 20 degrees was the vertex angle of the isosceles triangle, which would not be good to use trigonometry on. So 10 degrees apiece, and let me figure out what they're trying to ask me for. They're asking me for what's the distance, what's the width on the forest floor that will be captured by the picture. So I'm looking for this yellow distance. So how much of the forest floor can the camera take a picture of at one time? To figure out the yellow part, I'm going to figure out the x part and then double it. So in my picture I'm looking for the opposite side, and there must be some other number in the question that I can use. Well, apparently the plane hasn't moved. This is the exact same instant as before. So I know that it's 1,000 feet from B to D, and that would be the adjacent side. So if I'm going into my trigonometry, it wouldn't be sine because I don't have the hypotenuse. It wouldn't be cosine because I don't have the hypotenuse. It would be tangent because of the ingredients that I have. So it would be the tangent of 10 degrees equals the opposite over the adjacent. Cross multiplying gets me the answer in just one step. So 1,000 times the tangent of 10, which is about 176.33. If I double that, I'll get the yellow part that I want. So the yellow part is approximately 353. We just double check the rounding. It just says what is the approximate amount, so it wasn't very specific. So 353. Last question, question D. It's asking me something else about how fast this plane is moving. It's traveling at a speed of 13 meters per second. Toward the fire, the direction towards the fire. Suppose that the altitude is now 800, so it's actually dropped down to a lower position. It's half a mile off the ground, about. The new position is represented by F, okay. From its position, how many minutes will it take it to fly directly above the fire? So I want to know how long it will take to actually fly from point F to point T. Well, I've got the angle. I know it's 800 here as well. If I knew how far it was, then I'll know how long it takes to get there. So I'm looking for the adjacent side, and I've got the opposite. So tangent will get me there, TOA. The tangent of 30 degrees equals the opposite side over the adjacent side. This one takes 2 steps to get the answer. Cross multiplying gets me close to the answer, and then dividing by the tangent of 30 tells me how far it will have to fly. So it's going to have to fly about 1,385.64 meters to get there. Now I got to turn meters into minutes. So check out the conversion. I want to get rid of the meters, and I know it's 13 meters for every second. So if I divide by 13, I will get rid of the meters and replace it with seconds. So it takes about 107 seconds to get there. They want minutes, so I want to get rid of seconds and replace it with minutes. And there's 60 seconds to every minute, so dividing that number by 60 tells me that the drone, with how fast it's moving, can get there in about 1.8 minutes.